Hi, this is Autumn Garibay, a classroom assistant for Applied Calculus, and I wanted to work through this problem. It has a lot of different aspects. We're going to be taking multiple derivatives, using some basic algebra, and be able to visualize it based on those things. So let's read it. Sketch the graph of the following function. List the coordinates of where extrema or points of inflection occur. State where the function is increasing or decreasing, as well as where it is concave up or concave down. And then the function is f of x equals 18x to the fourth minus 108x squared. So the first part of this question is, what are the coordinates of the relative extrema? Select the correct choice below, and if necessary, fill in the answer box to complete your choice. And there are two options. So the coordinates of the relative extrema are blank, or that there are no relative extrema. So extrema for us is going to mean maximums and minimums. So those tops of the hills and bottom of the valleys, and how we're going to identify them is their slope, or the slope of their tangent line, or how we'll find it is the derivative is going to be 0, and it's going to be a flat line like that. So that first requires us to take the derivative. So our function f of x is 18 x to the fourth minus 108 x squared. And we are going to find the derivative, which is f prime of x. So we're going to use the power rule, which, if you don't remember it, the derivative of x to the n is going to be nx to the n minus 1. So that said, we're going to bring this 4 down. Let's see, 4 times 18, 72. X, 4 minus 1 is 3. And real quick, I'm going to do 108 times 2, 216. You can do this in your head, but I like to use a calculator to double check, make sure you got your arithmetic right. Again, that 2, you subtract 1, you get 216x. So this is our derivative. So we can find the slope at any point, but what we really want to know is the slope at these points where it's going to equal 0. So we're going to go ahead and set that value equal to 0. And now we solve for x. And there are a few ways to do this, but I think the easiest one for this is going to be factoring. So we want to take what these terms have in common and take it out. So they have this x cubed and an x, so we know you can take an x out. Let's see what else we can take out. The 216, be nice if we could take out a 72, and we can. So let's take out 72x. So you divide 72x to the cube, x to the third, by the 72x, you get x squared, minus 216x divided by 72x, you get 3. And we're setting that equal to 0. So now that we have these two things equaling 0, we know either this equals 0 or this equals 0. So let's consider both of those cases. Either 72x equals 0. It's pretty easy to see. You can divide 72 by both sides. 0 divided by anything is still 0. So, and x is going to equal 0 in that case. Our other case is x squared minus 3 equals 0. We can add 3 to both sides. X squared equals 3. We can take the square root of both sides. And it'd be really easy to say, oh, look, x equals the square root of 3. And that'd be partially correct. But when you're taking the square root, you want to be really conscious and realize that there's going to be a positive and a negative, because a negative times a negative equals a positive. So if you were to square that, you get the same value as you would if you had that positive root. So this is going to be positive root 3 and negative root 3. And of course this 0. So these are our 3 x values where our function attains a maximum or a minimum. So, but it doesn't just want the x values, it wants ordered pairs. And an ordered pair is x comma y. So we have our x, we need to find our y. And we're going to do that by referring back to our original function and plugging each of these values in. So let's do that. And for time's sake, I am going to use a calculator. So 18, and then we'll plug in, let's plug in negative square root 3 first. 3 to the 4th minus 108 square root 3 squared. Let me put parentheses around. Oh, and I actually did plug that in a little wrong, so we want to make sure we have that negative. So we have, this gives us negative 162. And you can find that by hand. Please do. I'm just saving us a little time. And if you are allowed use of a calculator, I say go for it. So we have that. Let's find it for positive root 3. And what do you know? We get the same answer because when we square our values, a negative times a negative equals a positive, and we get the same value because they end up being the same value squared, or raised to the 4th power. 0 is going to be even easier, so when we plug in 0, we have 18 times 0 minus 108 times 0, which is just 0. So let's write these as ordered pairs. That's going to be x, y, so root 3, negative 162, negative root 3, negative 162, and 0, 0. A little out of order, but I am quite sure MyLabsPlus will take it. Let's see if that's right. Make sure you're plugging everything in right. What's under the square root should be under the square root and nothing else. We have 3 answers, so we're going to separate our ordered pairs by commas. We have negative root 3, comma, negative 162, another comma, and 0, 0. All right, let's see if that's right. Nice work. All right, now it's asking, what are the coordinates of the inflection points? So select the correct choice below, and if necessary, fill in the answer to complete your choice. So we know that our maximums and minimums, what they call our extrema, are where the slope goes from increasing to decreasing, or from decreasing to increasing. Inflection points are a little different. It's where the function will be changing from curved down to curved up, and we call that concavity. So this is concave down, I think concave down like a frown, and this is concave up, or concave up like a cup. That's how I remember it. And this will all be based on not the first derivative, but the second. So we have f prime of x here. We're going to find f double prime of x. That's how we denote the second derivative, and it's really just taking the derivative of the derivative. So let's do that. So real quick, 72 times 3, again using the power rule, it's going to be 216 again. X, 3 minus 1 is going to be 2, minus 216. And that works out to be really convenient because we have a 216 and a 216. Let's factor that right out. We have x squared minus 1. We're going to set that equal to 0 because that's where it's going to change. And solve. So you can divide the 216 away. So we really have this x squared minus 1 equals 0. And if you can recognize that that is what we call a difference of squares, then it factors very nicely. It factors into x plus 1, x minus 1 equals 0. So we know that either this equals 0 or this equals 0. So each of those cases, if it's plus 1, then x is going to equal negative 1. If it's minus 1, then x is going to equal positive 1. So here we have 2 inflection points at x equals negative 1 and positive 1. But again, they want them as ordered pairs. It matters where the y values of this are. So we're going to plug them right back in to f of x, which we still have up here. So I'm going to plug in -1. It's going to equal -90. Oh, I'm sorry, this is for -1. And +1, even though likely it'll also equal -90. Yep. So here we have two more ordered pairs. Let's write them out. So for -1, we get out -90. And when we put in +1, we get out -90. Oh, no, negative. +1, -90. All right, let's put that in, see if it's right. -1, oh, remember parentheses? I like to put them both in just so I make sure I'm not missing one. All right, -90. Separate your answers with a comma. 1, comma, 90. -90, forgive me. All right, so let's check that answer. Excellent. All right, let's move on. On what intervals is f increasing or decreasing? So this will actually refer back to our derivative because, like we said, that's referring to slope. If slope is positive, it's going to be increasing. If slope is negative, it's going to be decreasing. And that changes at our extrema points. So let's draw those out on a line. So remember the x values of our relative extrema were -√3, that's about 1.7, 0, and +√3, about, oh, not negative, about 1.7. And we know that the slope is 0 at each of these. What we don't know is what's leading to that 0. Is it decreasing? Is it increasing? So let's see what's happening around these points. So we're going to pick points in between and to the left of right of each of these points, and we'll plug them into our derivative to see what the slope is doing at that point. So something to the left of -√3, probably -2. Something in between that and 0, let's say -1, and let's choose the positive parts of those values as well. So now we need the derivative. Let's scroll back up to that. So we have 72 to the third minus 216 x. And what were those values again? So -2. Again, this can all be done by hand, but it can also all be done by calculator, your choice. All right, so we got -145. What matters with that is the negative. So we have a negative there. Let's plug in -1. +144, great. So we have a positive here. We have +1. -141. Again, that negative is really important. I see a pattern, but let's not be too hasty. Let's plug in 2, see what we get. And +144. So we have a positive here. So remember, these are changing at these points, and it's going from where it's negative, it's going to be decreasing, increasing, decreasing, increasing. So it looks a little like that, but a little smoother. And we can say this in interval terms as well. So up until -√3, we can see that it's decreasing. And we only plugged in 1 point, but we know everything to the left of -√3 is going to be negative. So, and that goes as far left as we can go, which we'll call -infinity. So from -infinity to -√3, it is decreasing. And from, in this interval, from negative root 3 to 0, we have a positive slope. It's increasing. What about the next one? We have 0 to positive root 3, and look at that, it's decreasing. So we're going to add that here. Our last interval, we have positive root 3 all the way off to infinity, and that's going to be increasing. So it starts at root 3 and goes to infinity. So here's how that looks. Let's see if there's an answer to match that. So f is increasing on negative 1 to 1. Well, we weren't considering those points to begin with, so let's move past that. Oh, B talks about negative 1 and 1. Let's move past that. C, f is increasing on negative 3 to 0. Let's see if that checks with ours. Sure does, negative 3 to 0. And from positive root 3 to infinity, f is decreasing on negative infinity to negative root 3, and on 0 to root 3. That's exactly what we have. Let's choose C. We can read the rest, but I'll bet you C works the best. Nice work. All right, on what intervals is f concave up or concave down? So we know what intervals it's increasing or decreasing. Let's do a similar thing, but instead of talking about the first derivative, we're going to be talking about the second derivative and seeing how that's changing. So we know it's 0 at negative 1 and 1. Let's choose points between those. So we have, let's say, negative 2, say 0, and positive 2. And we'll be plugging those into f prime of x, which, we scroll back up, that's 216x squared minus 216. So 216 times negative 2 squared minus 216. All right, and when we plugged in negative 2, we got 648. That's positive. Let's see if we plug in 0. Actually, we can do this by hand. It'll be 0 minus 216, so that'll be negative. Let's do positive 2, and we get positive 648 again. So, like I said, this is more talking about how it curves more than if it's going up or down. So if it's concave up, then concave down, then concave up. And it'll look a little like that, which actually, would you know it, kind of looks like a smoother version of what we had up here. So that's a good sign. So now let's break that up into intervals. We had this interval where it's concave up, so let's write that as negative infinity to negative 1, and that's concave up. This interval was from negative 1 to positive 1 is concave down, and this interval from positive 1 off to infinity is concave up again. Let's see if there's an answer that matches that. So f is never concave up. We know it is concave up. B, f is concave up on negative infinity to negative 1, and from negative 1 to negative infinity is never concave down. We know it's concave down, so C, f is concave up on negative infinity to negative 1, and from 1 to infinity, f is concave down on negative 1 to 1. That's exactly what we have. So let's choose C, see if it works. Fantastic. So now we can kind of graph it, and we kind of did that with these. So let's look for something that's vaguely a W shape. We can see that A and C have more of an M shape, so let's focus on B and D. Both look promising. However, D is a little off-center, and B is perfectly symmetrical. And I think that that will be a little more promising because we have a maximum at 0 and at positive root 3 and at negative root 3. Those are kind of equidistant, and we have a maximum right at the origin, and that's what B shows us. So we don't have to do any fancy graphing. All the work we did kind of gives us a sense of what this should look like. So let's see if that's right. Good job. And Actually, to you, good job. Thank you for watching and hopefully for working through this as well. So what we did, we found extrema points, inflection points, where it was increasing or decreasing, where it was concave up and concave down, and even what the function looked like based on all of that. So I hope that this gave you a better understanding of those concepts, and please have a great day.